Everything changes. There's no need to say anything profound about time. We can't really imagine anything without it, and so on and so on. How about time in our designs, though? Along with planning for change, planning for an idea to take shape over time, letting a design be shaped by its occupants or its users, letting it grow into its full potential. We can also incorporate time into the generation of a design. We can press play on a simulation and see how a design adapts to or becomes part of its environment. But probably much more obvious than all of this is the usefulness of time and how we communicate our ideas as designers or as researchers or just as human beings. Communicating ideas is, well, beyond important. Designers are used to and get very good at making pictures or diagrams to help us with this, but more and more animations and videos are becoming the obvious way to go. Picture plus time equals animation or video. A picture is worth 1,000 words and an animation is 1,000 pictures. The math might not all add up, but animations are wonderful nevertheless. We know that. I think they're great. I'm pro animation or video, and you can do way more with animations in Grasshopper than you might think. This tutorial is a way to get us started with that. A very straightforward way to bring time into Grasshopper is to put a counter on your canvas and hook it up to whatever you want to change through time. So we're going to do that. And we won't just make one counter though. We'll make a component to make as many counters as we want. For us in this tutorial, there'll be counters for animations, just some animation counters. Once we have this component, we'll make a couple quick animations with it. We'll animate some simple geometry and we'll animate a drawing. Okay, so let's open up Grasshopper, and I'll go into perspective view. We won't need that right away though. We can actually maximize this window so that we can see it a little bit better. So the first part of this tutorial is just making this C# component, and this is a very handy component to have. I use it all the time. It's basically just a counter, something that counts for you, but we get multiple counters out of it. So I'm going to type in C#. And I'll name it right away. So what I have it named as is row your boat. And this helps me remember what it does. Row your boat, like the kids song that's sung in rounds. So the output of this is going to be a list of counters, each one starting somewhere after the one before it started, or maybe after the one before it ended. We can choose when exactly the next counter in the list starts to count. And there are going to be 4 inputs. The first one we'll call reset, R-E-S-E-T, and this is going to be a Boolean. Let's get 2 more. And then this one we can call counters. This is just going to be an integer. This is going to be the number of counters that we have. This one we'll call speed. So how fast do these counters go up? And this is going to be a double. And the last one we'll call wait for. And this is also going to be a double. So this one's going to tell us when to start the next counter in the list. They'll all start at 0, and then the first one will go until we hit some number between 0 and 1. And when we hit that number, then the next one in the list will start. So let's get a button. And we're just going to click this every time we want all of the counters to go back to 0. And then we'll just start with 5 counters. Speed is going to be a number between 0.001. We can't have 0 because then we won't be counting anything. This is just how much each step goes up by. And we wouldn't really want 1 either, because then they would all just fly up to 1. But we'll just set it to something like that for now. And then wait for 0.001 less than 1. So let's double click on the C# component. Actually, before we go in here, I'm going to close this for a minute. I do know that we're going to want another output, so let's make sure we have A and B coming out here. And then we'll double click here to go inside. I'm just going to get rid of all of this. I'm going to get rid of the end region. And we don't need this note there either. I'm going to double click after the run script. So this is the run script function. We need some persistent variables out here. We need some things that have memory each time this script runs. 3 of them actually. First we're going to have a list, and that's going to be our list of counters. And so every time this component updates, those counters are going to increase by the amount that we set our speed to. So let's make that list. And again, we're making it outside of the run script component so that it doesn't reset every time the component is run. So we'll say private list double, or you can just write list double if you want, but it's probably good to get into the habit of labeling things public or private if you know what you want. And then we'll call this counter list. This is just our list of counters. And then it's going to be equal to, we'll set it equal to a new empty list, doubles, parentheses, and then the next variable we need outside here is an integer. And this one we won't actually use today, but it's good to write this into your component. This is something we'll call file number. And because this component is going to be really helpful for making animations, essentially, obviously an animation is just a sequence of images. And so this file number can be used to name images in a sequence. This will increase by 1 every time the component is run. And so we can have like image 1, image 2, image 3, image 4, and this will just give us that those numbers. So we'll set it equal to 0 outside here. And then last, we'll say private boolean just reset. And this, we'll set it equal to false to begin with. And we're going to use this variable to make sure that all of the lists are set to 0, because the button that we use to reset, as we click down, it says true, and as we let go, it says false. And so that's two different triggers. And unless we have something like this, and we'll go through how this actually works when we see it in the script up here, but this is just something that makes sure that the first item in the list always is set to 0 when we click that reset button, because we want all zeros. We don't want the first one jumping up an amount equal to the speed each time we reset it. So we'll say this is just like a flag that indicates if the script was just reset. And then let's go make the reset up here. The first thing we can do in the run script function is say if reset. So if we click that reset button, what do we want to happen? We want our counter list to go back to all zeros. But first we'll just clear it. So counterlist.clear. The next thing we want to happen is let's set our file numbers all to 0. Or our file number back to 0, and then let's set just reset to true. So this flag that tells it if it's just reset, we're going to set it to true because we just reset it. So if we click the reset button, we want all this to happen, but if we haven't just clicked the reset button, then we say else. We're going to do our normal counting up inside this else. So the first thing we want to do is say file number plus plus. We want to increase that file number by 1. And then the next thing we want to do is check to see if the counter list has been populated with the appropriate number of counters. We want to make sure, again, remember, when we press the reset button, when we're clicking down, it says true, so all of this is going to happen when we click down. And then when we let go, this will say false. So we'll skip right down to here. So after we click it, this counter list is going to be completely empty. There's going to be nothing in there. But we want to fill it with the correct number of counters. So we say if counterlist.count is less than counters. This is just to check to see if we've done this step yet. So what we're doing here is just initializing all counters to 0. So we'll say while counterlist.count is less than counters. We just need to add another counter in that list. So counter list.add 0.0. We want them to all start at 0. So that's just initializing our counters. Then we'll do another if. If just reset, then we want to change this back to false. And the reason we're doing this is there's going to be two different pathways it can go down. If just reset, then that means we just reset it. The only thing it's going to do is just change that to false. And then we'll just sit there until the component is triggered again. But if it's not just reset, meaning it's being triggered and we actually want to count up, then we're going to say else, and we'll do our counting inside of this else. We'll say for int I equals 0, I is less than counterlist.count I++. And the first thing we can do inside of this for loop is check to see if we've hit that wait for yet, or if this is just the first one in the list that we're counting up on. So there's going to be an or. We're going to do another conditional. We'll say if, and there's going to be an or inside of here. So if I is equal to 0, or counterlist I minus 1 is greater than or equal to wait for. So those are the two conditions in which we would want to add to whatever list I we're on. If I is equal to 0, then we'll be adding to that list no matter what. Or if we've hit the wait for value on the previous counter, then we want to be adding to whatever list we're on in I. And we're only going to count between 0 and 1. These counts are just going to go from 0 up to 1. And that's a very obvious choice because we can scale that to whatever numbers we want very easily outside of this component. And so inside of this conditional, we want another conditional that checks to see that we're somewhere between 0 and 1, or that we haven't passed 1 yet. So we'll say if counterlist I is less than 1, then we can increase that counter by whatever the speed is. So we'll say counterlist I plus equals speed. But if adding this additional speed puts us over 1, we want to bring it back down to 1. So we'll say if counterlist I is greater than 1, then counterlist I equals 1. And so that's it. If I haven't made any mistakes, I'll copy this. We'll bring the counter list out of A, and then out of B, we'll bring our file number, this variable here. Okay, now let's get a couple panels to see what's coming out of these outputs. So that's good. We have 5 items in this list, all at 0. And then this is our file number starting at 1. Let's get a trigger. If you haven't used this component, it's super helpful if you're doing things like animations or simulating an environment where you want to include time into that, if you're doing some kind of growth or something like that. And this is going to hook right up to our C# component. So I just pulled this out and put it on there. And what this does is it just triggers, every time you click this, we're going to count up by an amount of speed. So every time I click the play button, it's going to trigger this component to run again. Let's reset it. But of course you don't have to click it every time. You can right click here and go to interval and set it to one of these. So we'll set it to 100 milliseconds. And you can see those all counted up to 1. Let's put the speed down a little bit lower. And let's go to 200 milliseconds and then watch how this goes up. So it just passed 0.75, and that's why the next one started. 0.75, now 2 are going at a time. Let's put this down there. Now we can get multiple counters going all at the same time. Or if we don't want the next one to start until the first one has finished, then we put wait for all the way up to 1. And we get something like that. Okay. And that's it for this one. Now we have a component to make as many counters as we want. In the next one, we'll start animating some geometry. But before you watch that one, maybe see what you could do with this counter. If you need a starting point, you've seen what's coming up next in the next few videos. See if you can make something like these, or make whatever's interesting to you. Make something that's crazy, or perplexing, or subtle, or just satisfying. See what you can do. Thanks so much for watching, and we'll see you on the next one.